Hello, everyone. Yesterday, I updated the results of assignment 3. And you can check the accuracy of your assignment. And the deadline of assignment 3 is today, 12 p.m. And I also updated the results of assignment 4. And in the results, there are two accuracies. For accuracy one is for task 1, computing the semester grade, while task 2 is for finding the most difficult quiz. And if the accuracy is not 100%, then this means there is some problem of your solution. So if the accuracy of your assignment is not 100, then you need to examine your program. You need to check the logic of your program to see where the problem is. And we are approaching the end of the semester. So in next week, I will announce assignment 5. So if you have not started assignment 4, you should start to write assignment 4. And in previous week, we learned how to use vectors. And the vectors is a data type from the standard template library in C++. And vectors is a dynamic array, and which can grow and shrink. And therefore, using vectors is very flexible compared to static array. And in this slide, introduce two functions of a vector. The size function returns the number of elements in a vector. So in this example, size will return 5 because this vector has 5 elements. And another related function is capacity. Capacity means the number of capacity means how much memory is allocated for a vector. And in this example, the memory of 8 elements are allocated for this vector. So for this example, the capacity is 8 because the memory size of this vector is 8. And the capacity is always equal to or larger than size. And in this example, I illustrate the difference between size and the capacity. And inside the inner for loop, push back 5 500 elements into the vector. So after the inner for loop, VEC will have 500 elements, and the outer for loop, will execute for 5 times. So for each iteration, 500 elements will be added to VEC variable, and then we print the size and the capacity of VEC. So for I equals 0, and for I equals 0, then after the inner for loop, then we see that the size of VEC is 500, because 500 elements are added to VEC, and the capacity of VEC is 512. This number is larger than is equal to or larger than size, and this number is determined by the implementation of the vector data type in STL. And when I equals 1, then after the inner for loop, and if we print the size of VEC, then the size of VEC becomes 1000, because 500 plus 500 is 1000, and the capacity is increased from 512 to 1024, because the capacity must be equal to or greater than size. And when I equals 2, then the size of VEC becomes 1500, and the capacity is increased again, because 1500 is larger than 1024, and the implementation of vector doubles the capacity. So the capacity is increased from 1024 to 2048. And when I equals 3, the size of VEC becomes 2000. And in this case, the capacity is not increased, because the capacity 2048 is larger than the size. So when the size of VEC is 2000, the capacity is not increased. And in the final iteration, when I equals 4, the size of VEC is 2500, and because the capacity is smaller than the size of VEC, so the capacity is doubled again. So the capacity becomes 4096, and you can change the number of iterations of this example to see the changes in size and capacity. this is the output of this example. And we can change, for example, we can change 500 to other numbers. For example, we can change it to 1000. And we can observe the changes in size and the capacity. So in after each inner for loop, 1000 elements will be added to VEC. And the right hand side is the corresponding capacity. And next, this slide introduces two functions related to memory allocation. And the first function is resize. And for example, we declare a vector v1. And in this statement, we only declare this variable, but we do not initialize this variable. So the size of v1 is 0. And in the next statement, we call resize function to allocate memory and to create instance. So the purpose of this function, resize, is to allocate memory space and also create instance. So this statement will allocate memory space for 100 integers and create 100 elements for v1. And after this statement, we can print the size of v1, which is 100, because resize will create 100 elements. And if we call v1 dot capacity, then capacity will return 100, because because resize allocates the memory of 100 elements. So capacity will return 100. And another related function is reserve. Reserve is similar to resize. Reserve also allocates memory space for a vector, but reserve do not create instance. So reserve only perform memory allocation, but reserve does not create instance. So after this function call reserve 100, and if we print the size of v2, the size of v2 is 0, because reserve do not create instance. So the size of v2 is 0. And if we compare 0 to 100, then this Boolean expression yields false. And if we print the capacity of v2, then capacity will return 100, because reserve allocates the memory space of 100 elements. So 100 is equal to 100, and this Boolean expression yields true. And next, this is the final topic of this slide. Consider the following two functions, the function declarations. The first function is read English names. This function is in the assignment 4. You can refer to the code template in assignment 4. Read student grades. This function is defined in the code template of assignment 4. And the purpose of this function is to let users input student names and save the names in this vector. To save names in this vector. And this variable is a vector of strings. Names is a vector, and each element is a string. And we will introduce the data type string in the next chapter. So string is a data type, like integer, double. String is a data type. So names is a vector of strings. So you can think this data type is like the array of strings. And for this, so the purpose of this function is to let users input student names and save the student names in this variable names. And the second function, display English names, assumes the names are already entered by the user. And the purpose of this function is to print the values of names. And below are some questions. The first question is, can we remove the const modifier in this function declaration? So the first question is, can we remove the const modifier in this function declaration? If the answer is yes, please raise your hand. If the answer is yes, if you think we can remove the const modifier in this function declaration, please raise your hand. And if the answer is no, please raise your hand. Oh, okay. Okay. The answer is yes. We can. The answer is yes. We can remove the const modifier. This modifier is not necessary, but we add this modifier here because we want to protect we want to protect. This is kind of protection to prevent we change the vector names in the definition of display English names. So this is to prevent we change the names in display English names. But if you remove this modifier, it is okay. But this will not affect this will not affect the usage of this function. And the second question is, can we add the const modifier in this function declaration? The answer is no, and we have already seen this question in the quiz. In the quiz, the question is that can we add the const modifier in this function declaration? And the answer is no. We cannot add the const modifier because the purpose of this function is to, because in the definition of this function, the values of names will be changed. So we cannot add the const modifier. And the next is about the usage of the and sign. So the first question is, can we remove the and operator in this function declaration? The question is, can we remove the and operator in this function declaration? The answer is no. Because if we remove the and operator, then this function is called by value, and the call by value means call by value means after this function call, you can refer to the code template of assignment board, and let's see the function declaration of read student grades. And here, let's see the function declaration of read student grades. And here we use the and operator because we want after this function call, we can access this array. We want to access this array after this function call. But if we remove the and operator, then we cannot access the changes in the changes of student grades in the function in the definition of read student grades. So the end operator is necessary in the function declaration of read English names. While for this function declaration, display English names. For this function, the end operator is not necessary. We can remove this end operator because this function only displays English names. So either call by value or call by reference will be okay for this function declaration. So for the second function, the end operator can be removed. But for this example, for this function, we include the end operator. The reason why we include this end operator is in the next slide. There are two scenarios that call by reference is used. The first scenario is when we want to change the contents of the object that you pass to the function. So the first scenario of using call by reference is after the function call, we want to access the value of the variable we passed to this function. So in this function call, we pass student grades, and in the function definition of read the student grades, in the definition of read student grades, the users we use cin to save values in student grades. So also this is number students, we use cin to save the number of students in this variable, number students. So we change the number of students in this line. But if we remove the end operator, then this will be call by value. Then the change will only applies to the local variable number students. But if we use the end operator, then the change to number students will affect the number students variable in the main function. So this is the first scenario where when to use call by reference. And the second scenario is when the object that you pass to the function is large. For example, if the object is a matrix with 10,000 integers, so the memory size of this object is very large. And if we use call by value, then this will consume much memory. So in this case, we will use call by reference instead. So when the object size or the variable size is very large, then we will use call by reference. So for example, if the vector of string, so if the memory size of names is very large, then we will use call by reference. So we add the AND operator here. And in addition, if the function does not aim to change the contents of the variable during the function call, then we can add a const modifier. So here we add a const modifier because display English names will not change the values of names. So we can add a const modifier here. And again, the const modifier is not you can remove the const modifier, but it is better to include const here because this keyword can prevent you to change the values of the names vector. And if you print the memory size of VEC names, and you also print the size of the memory address of VEC names, you will observe that VEC names occupies 12 bytes, while the size of the memory address only takes 4 bytes. So if we use copy by value, if we use call by value, then we need to copy 12 bytes. But if we use call by reference, then only 4 bytes will be will be copied. And we have finished vectors, and we are going to the next chapter, strings. This chapter has 3 parts. The first part is about the strings in the C programming language, which is called C strings. And the second part is the data type string in the C++ programming language. And the third part is about input and output, about characters and strings. And first, let's see what is a C string. A C string is an array of characters. So it is like this one. A C string is an array of characters, and the C string has one additional requirement. The requirement is that the end of this array must contain the null character. The null character is \0. This is called the null character. A C string, the last element of the C string must be the null character. So in this example declares a C string. This variable is an array of characters, and the last character is the null character. So in this example, we declare a C string. But the next example is not a C string, because the last character is not the null character. So this example is an array of characters, but this array is not a C string. So C string is inherited from the C programming language, and it is an array of characters, and the last element of this array is the null character. And the second part of this chapter will introduce the string class. This is a data type in the C++ programming language, and we recommend using C++ string instead of C strings, because it is more convenient to use C++ string, and this will be demonstrated in the next part. And let's consider the initialization of C string. We can initialize a C string like this statement. We can declare an array and give initial values. And here we do not specify the array size, because the compiler can infer the array size from this initialization. This initialization contains 4 characters, so the array size of this array is 4. And there is also another way to initialize a C string. We can use the double quote. And the first line is equivalent to the second line. So you can use the double quote to initialize a C string, or you can use the braces to initialize a C string. The first way is more convenient, because you don't need to type many single quotes. So the first way is more convenient to declare a C string. And we know that if we use this way to declare a C string, the null character is implicitly added in this, because in the double quote we do not see the null character, but the null character is implicitly added in this in the show string, and you can print the array size. And if we print the size of short string, we see that the size of short string is 4. Because this array has 4 elements, A, B, C, and the null character. So the size of this character array is 4. The null character is implicitly included in this array. And the third line is not a C string because for this example, the last element is not the null character. And the next we consider if we specify the memory size in the brackets. For example, if we specify the memory size, the array size is 5. But on the right hand side, the initial value is ABC. And for this example, the initialization is ABC, which is equivalent to the double quote ABC is equivalent to this initialization. And but on the left hand side, the array size is 5. So one remaining character is not specified because on the right hand side we only specified 4 characters. But the array size is 5. So one remaining character is not specified. And according to the rules of the C++, the remaining character will be assigned the value of 0. If you see the slides in the if you see chapter 4 arrays, and if you go to the initialization, if you go to the array initialization, the remaining elements, remaining elements will be assigned by the values of 0. So for this example, we declare an array of 5 elements, but the initialization only give 2 integers. And the remaining 3 elements will be set to 0. So for this example, the remaining 1 elements will be set to 0. And so this line is equivalent to the last statement. And actually, the integer value of the null character is 0. In fact, each character corresponds to an integer, and the integer value of the null character is 0. You can check the Ascii table of C++. And this table will list the integer values of each character. So for the null character, the corresponding integer value is 0. While for the character A in lowercase, the corresponding integer value is 97 in decimal. So for this example, for this example, the remaining element is set to 0, integer 0, and the integer 0 corresponds to the integer 0 is equivalent to the null character. So the last two lines in this slide are equivalent. And there is one link. This link is about the survey of midterm student evaluation of English course. Of course, taught in English. And if you have not complete this survey, please complete this survey during the break time. And your suggestion can help the school to improve courses taught in English. And let's take a break for 10 minutes. Hello everyone. Let's continue our class. Next, we will have a quiz, and raise your hand if you need papers. Uh, 30 seconds left. And I will close this question. Uh, 30 seconds left. And I will close this question. 30 seconds left. And I will close this question. If you use paper, remember write down your student ID and name. And forward your paper to the first row. Forward your paper. And let's see the answers of the 3 questions. And the answer of the first question is A and C. In this question, we made a function call phi. We made this function call, and this question asks what is the possible function declaration. And there are 3 choices. The answer is A and C. Because the inputs are integers. Because hours and minutes are integer variables, so option A is correct, and option A is possible, and option C is also possible. Option C is called by reference, so option C, A and C are possible, but option B is not possible because the input data type is int star. So the data type is incompatible. The input variables of function phi are integer. The data type of input variables are integers, while the input data type of option B are pointers. So the data types are not compatible, and therefore B is not possible. B is not the possible function declaration. And let's see the next question. The answer is B and C. Consider 3 types of containers. The first one is array, and the second one is dynamic array, which is created by the new and the delete operator. And the third container is vector. And which of the following statements are true? in terms of maintenance cost, we should choose vector because vector can automatically allocate memory, and vector can also automatically return the memory. So if we use vector, we can reduce the maintenance cost. But if we use dynamic array, we need to manually new and delete memory. So in terms of maintenance cost, we should use vector. So we should choose B. And in terms of memory efficiency, we should use dynamic array instead of array. Because if we use array, we need to specify the maximal size of the array, and this may waste memory. Let's see. Because if we declare an array, then we need to specify its array size, and thus we need to declare the array size to be the maximum. We need to specify the maximum number of elements, and this may waste memory. So, but if we use dynamic array, then we can manually change the array size. So this is more efficient. So the answer is BC. For this question, the answer is unknown. The answer is unknown. I declare VC1 to have 5 elements. So the size of VC1 is 5. And I declare VC2 to be the copy of VC1. So VC2 also has 5 elements. So the size of VC2 is 5. And next we use a for loop to access the elements of VC2. And we know that the index begins from 0. And the Boolean expression is I is less than or equal to 5. When I equals 5, when I equals 5, 5 is outside the legal range of VC2, because VC2 is of size 5. So the legal index are 0, 1, 2, 3, 4. So when I equals 5, VC2 bracket 5. The value of VC2 bracket 5 is unknown, and therefore the value of sum is also unknown. So the answer of this question is unknown. And it is important to make sure that the index is in the legal range. So this is a common mistake appear in the assignments. If no further question, we will return to the mistake is about this expression. When I equals 5, I is outside the legal range. Yes, this one is correct. We will return to strings. So if we declare a C string in this way, then this statement is equivalent to the last one. The last statement. On the right hand side, specified 4 characters, A, B, C, and the null character. And on the left hand side, specifies 5 elements, and the remaining elements will be set to 0, and the 0 is the same as the null character. And you can take a look of the Ascii chart, and this table records the integer values in decimal or octal or hexadecimal for each character. And for the null character, the integer value is 0, corresponds to 0. So if we declare an array of characters of 5 elements with initialization, and this corresponds to 5 characters. The first character is H, the second character is I, and the last 3 characters are the null characters. And we can print the value of the character array, or we can suppose we declare my string in this line, and we can use a for loop to print the values in this C string. And the console output will print A, B, C, and it will also print the null character. But the null character is invisible, so we cannot see outputs after C, because the null character is invisible. This for loop will print 5 characters, and the last 2 characters are the null characters. And because the null character is invisible, so we cannot see characters after C. And we can also change the data type of the element of my string. For the data type of my string I is char, which is character. We can change its data type to integer. So we made a type casting here. We change the data type from character to integer. And if we do this, then we can print the integer value of the character. And the integer value of character A is 97. And you can look the Ascii table. Character A corresponds to 97. So the first iteration will print 97, and the second iteration prints character B, which corresponds to 98. And the third iteration print character C, which corresponds to 99. And the fourth iteration prints the null character, and the null character corresponds to integer value 0. And the fifth element is also the null character, which corresponds to integer 0. And we can also perform subtraction to characters. If we subtract characters, this will perform integer subtraction. And if we perform my string I subtracts character A, then this will corresponds to the integer value of my string I minus the integer value of character A. So for the first iteration, we have 97 minus 97. So for the first iteration, the result is 0. And for the second iteration, we have character B minus character A, and the character B is 98, while character A is 97. So the result is 98 minus 97, which is 1. And for the second iteration, we have character C minus character A, and which corresponds to 99 minus 97, and the result is 2. And for the fourth iteration, when I equals 4, my string I is 0, and 0 minus 97, and we have negative 97. Next is about the assignment and the comparison with C strings. And we cannot use the equality. We cannot use the assignment operator and the equality operator for C strings. Here, a string is an array of characters, and we cannot use the assignment operator to assign a C string to the character array. This is illegal because the character array does not support the assignment operator. And to assign one C string to an character array, we need to use the function string copy. strcpy is string copy. We need to make this function call, and this function call will copy the C string hello to the character array A string. And we cannot use the equality operator to compare two C strings. So it is illegal to directly compare C strings with character array, because the character array does not support the comparison operator. And to compare two C strings, we need to use strcmp, which is string compare. And the string compare is a function, and this function will return 0 if the two input strings are the same. And this function returns a negative value if str1 is less than str2. We will explain how to compare two strings in the next chapter. And strcmp returns a positive value if str1 is greater than str2. So to compare two strings, to compare two C strings, we need to use strcmp. And this is less intuitive, because the most intuitive way to make assignment is to use the assignment operator. And the intuitive way to compare two strings is to use the equality operator, but C string does not support the two operators. Below are two functions related to C strings. The first function, strlen, is string length. This function returns the length of the input C string. For example, if we declare a C string with initialization like this, and we can call strlen to strlen will return the string length, and the string length is does not include the null character. So the string length for this example is 6. the string length does not include the null character. And you can do some practice to print the string length and print the memory size of my string. And to use these functions, we need to include the C string library. This is a library in the C programming language. Here I print the length of my string, which is 6, because the C string has 6 characters, and the null character is not included. But if I print the size, the memory size of my string, the memory size is 10 because each character is 1 byte. Each character has 1 byte, and the array has 10 characters. So the memory size of my string is 10 bytes. If we omit the array size, or if we omit the array size, then we compile this program. And you see that the string size is different. The string length is the same. The string length is 6 because my string has 6 characters. But the size of my string is changed. The size of my string is 7 because my string has 7 characters, and the last character is the null character. And if we want to perform string concatenation for C strings, we need to call string cat. String cat means string concatenation. For example, suppose the character array words is the ren, is the C string, the ren. And now suppose we want to concatenate this C string with the second C string in span. Suppose we want to concate the 2 C strings, then we need to call this function string cat. And the result will be saved in words. here we perform string concatenation, and after this statement we print the character array words, and the values of words are the range in span, which is the concatenation of the first string and the second string. But to use this function, we need to ensure the capacity of the first argument words is sufficient large to contain the string after concatenation. So we need to ensure the capacity of this character array is not large enough to contain the range and to contain in span. If the capacity is not large enough, sufficient, then this will cause some error. For example, if we change I change the array size from 20 to 10, and then I run this program again, and we encounter a runtime error. This runtime error is stack smashing detected. This means the memory size of the first input of strcat is not sufficient large. So we need to manually compute the size of the first C string and the size of the second C string to ensure that the capacity of this character array can contain the two C strings. But this is very inconvenient. This is very inconvenient. In the next slide, in the next few slides, we will see if we use C++ string, we can avoid such inconvenience. And the four functions are defined in the C string library. So if we need to use one of these functions, then we need to include the C string library. And you don't need to memorize these functions. So the final exam will not. You don't need to memorize the usage of these functions. Next, let's see the implementation of STI or EN. This will allow us to understand the mechanism of the C string. The input of stren is an character array, and we add the const modifier because we don't need to modify the values of array inside the implementation. And the return data type is an integer, And because we want to return the length of the string, so the returning data type is integer. And first we declare an variable index, and index begins from 0. And we use a while loop to check whether array at index is equivalent to the null character. If array at index is not equivalent to the null character, then we increase the index by 1. But when we reach the null character, then the while loop terminates. And when the while loop terminates, then index is the length of the string. So we return, when the while loop terminates, we return the index, and the index will be the string, will be the length of the input array. And let's take a look for take a break for 10 minutes. Hello everyone, and let's continue our class. Next, I will introduce functions defined in the CC type library. And this library is also inherited from the C programming language. The first function is to upper. The input is a character, but we know a character. We can also use an integer to represent a character. So here, the input is an integer, but you can also treat the input as a character. And for this function, the output returns the uppercase version of the input. But if the input is not an English letter, then the output will be the same as the input. And the next function is upper. The input is also a character. And if the input is an uppercase letter, then this function returns a non-zero value. Otherwise, this function returns 0. And the next function is alpha. Alpha means alphabet. This function, if the input is a letter of the alphabet, and then this function will return a non-zero value. Otherwise, this function returns 0. The next function is digit. If the input is one of the digits 0 up to 9, then this function returns a non-zero value. Otherwise, this function returns 0. And the next function is Alphanum. If the input is either a letter or a digit, then the function returns a non-zero value. Otherwise, this function returns 0. The next function is space. If the input is a white space, and here white space means either of the 3 characters, the space character, the tab character, or the new line character. So the 3 characters are called white space characters. And if the input is a white space character, then this function returns a non-zero value. Otherwise, this function returns 0. The next function is punctuation. If the input is a punctuation character, punctuation character means a printing character other than white space, a digit, or a letter. So a punctuation is like comma, semicolon at the center. So if the input is a printing character, then if the input is a punctuation character, then this function returns a non-zero value. Otherwise, this function returns 0. And the next function is print. If the input character is a printing character, printing character means the console can print this vector. Some characters cannot be printed, like Control C or Control A. Also, Control C, Control A are characters that cannot be printed. And if the input is a printing character, then this function returns a non-zero value. And again, you don't need to memorize these functions. You don't need to memorize the usage of these functions for the final exam. Below, I will use an example to illustrate the effects of these functions. And I write a function, a display string. The input is the input is a C++ string, or the input can be a C string. The input can be a C string or a C++ string, and we will introduce C++ string in the next slide. And the second input is a function. The function is like is alpha, is lower, is punctuation, and so on. So the second input of the function is a function, and we need to specify the data type of the second input. And here we need to use the function pointer to define the data type of a function. And this is an advanced topic, so you can omit this. If you can omit this function pointer if you find it difficult. And here, C type, FU1C is the data type of this function. And this function is like is alpha, is lower. And inside display string, we use a for loop to access the element of stri. Str is the input string, and the stri is the element of str. And we will paste this character as the input of UNC. So stri will be the input character of FUNC. And we print the output of FUNC. And for each I. And for example, suppose the input string is hello, comma, and the space welcome, and exclamation. And if we let str be the first input of this function, and the second input is the is alpha function. Its alpha function is in the previous slide. Is this function. And the next, I show the results of this program. I show the results of this program. The input is hello, comma, space, and the welcome exclamation. This is the input. And I add a space. I use stay with. I use the function stay with to align the outputs. And let's see the output of the first function call. Let's see the output of the first function call. The input function, the second variable is the is alpha function, and the CR will print the return value of the is alpha function. So if the input is h, then the return value of is alpha is non-zero, and which is 1, because h is in the alphabet. So is alpha returns a non-zero value 1. You can see the usage of this function. If the input character is in the alphabet, then this function returns a non-zero value. So if the input is h, then its alpha returns a non-zero value 1. And if the input is letter E in lowercase, then letter E is also in the alphabet. So this function returns a non-zero value 2. And the non-zero value are different for uppercase or lowercase. While if the input is a comma, and because because comma is not in the alphabet, so this function returns 0. And similarly, the space character is not in the alphabet, so its alpha returns 0. And similarly, for this punctuation is also not in the alphabet, so its alpha returns 0. And let's see the second function call. For the second function call, the second input is lower, and the output of is lower is shown in this row. If the input is the h in uppercase, and because h is not in lowercase, so this function returns 0. If the input is a letter in lowercase, then is lower returns non-zero value. So ELLO is lower returns non-zero value. And if the input is a comma is not a letter in lowercase, so lower returns the value of 0. And the space character is also not a letter in lowercase, so is lower returns the value of 0. And let's see the third function call. The the second input of this function call is punctuation, and the output of the third function call is in this row. And here h is not a punctuation, so this function returns 0. And E is also not a punctuation, so its punctuation returns a 0. But for comma is a punctuation character. So for comma, the is punctuation function returns a non-zero value. And the value of this number is determined by the implementation of the functions. So this value depends on the implementation of the CC type library. And we also see that the space character is also not a punctuation. So its punctuation returns 0. And you can download this program. This program is in the reference page. You can go to the reference page in the course website, and you can find the strings item. Below are some demo programs. Then you can download this one, test C type. And if you download this program, then you can see the outputs of this. You can see if you download and compile this program, and you can generate the outputs in this slide. Below, I show how we can implement the isLower function. So in this slide, I implement the isLower function. And here, IMPL means implementation. And the input is a character. And the output is an integer. If the input is a lower, if the input is later in lowercase, then we should return a non-zero value. And here the non-zero value is 2, because I follow the convention in the CC type library. And if the input character is not a case, if the input character is not a later in lowercase, then this function returns 0. So we need to check whether the input character is later in lowercase. Then we can use this expression to check whether CH is in lowercase. Here we compare CH with character A. We can directly compare CH with character A. And we also compare CH with Z. If the two comparison if the two comparisons are satisfied. So we use the AND operator to combine the two inequalities, can combine the two results, the results of the two inequalities. So if the input character is greater than A, and the input character is less than, if the input character is greater than or equal to character A, character A corresponds to integer value 97. If the input character is equal to or greater than 97, and if the input character is equal to character Z, character Z which corresponds to 122, if the second inequality is satisfied, if both the two inequalities are satisfied, then we know CH is in lowercase. Then this function returns 2. And to verify whether CH is in lowercase, we don't need to look up the table. To verify whether CH is in lowercase, we don't need to look up the table to know the integer value of A. So here we don't need to know the exact integer value of A, of character A. So we don't need to write our program in this way. We don't need to know the integer value of A. We can use character A to represent the integer value. So the following two if are equivalent. We can use the first way or the second way. The first way, we don't need to use the integer values of characters. While the second way, for the second way, we need to look up the table. We need to look up the table to know the integer value of character A is 97, and the integer value of character Z is 122. So if you want to implement XOR, which one will you choose? So if you want to implement XOR, you will use the first method or use the second method. If you prefer the first method, please raise your hand. If you prefer the first method. Okay. If you prefer the second method, please raise your hand. Okay. In my opinion, the first method is better. The first method is better because the first method is more readable. You know this comparison compares CH with character A. But for the second method, the second method is less readable. You need to look up the table to know what does 97 mean. You need to look up the table to know what does 122 mean. So the second method is less readable. So if so, to make your program more readable, I think the first method is better. And the next slide is the implementation of is alpha. And the is alpha, if the input of is alpha is in the alphabet, which means it is either in lowercase or in uppercase, then this function will returns non-zero values. Otherwise, if ch is not in the alphabet, then this function returns 0. And let's see the implementation. The input is ch, and the first we call the function is lower. Is lower. The implementation is lower is here, and is lower can determine whether the input is in lowercase, and the result is saved in the flag variable. And if flag is non-zero, this means ch is in lowercase. So we simply return a flag. And if flag is non-zero, is 0, if flag is 0, then this means ch is not in lowercase. If ch is not in lowercase, then we go to the else part. Then we need to check that whether ch is in uppercase. If ch is in uppercase, then flag is non-zero. If ch is in uppercase, then flag is non-zero. But if ch is not in uppercase, then flag is 0. In both cases, then we can directly return flag. And you can verify that this implementation implements the behavior specified in the usage of is alpha. And next is a demo function to demo the use of to lower and to upper. And this program is similar to the one this program is similar to the test C type. And the first input is a C string or a C++ string, and the second input is a function to lower or to upper. And to lower will, so here func is either to lower or to upper, and we print the value returned by func. And here I perform static cast, because if you don't perform typecasting, the output will be an integer. And here I perform typecasting to change the data type from integer to character. So we can see the outputs in character. And suppose the input is hello world in in lowercase, and then hello world in uppercase. Suppose this is the input C string, and then I show the result after the first function call. The result of the first function call. And to lower, and if your input is already in lowercase, then the output remains the same. Or your input is a space, the output is also a space. But if your input is in uppercase, then the output of to lower is the lowercase version of the input. So for example, your input is W in uppercase, then the output of to lower is W in lowercase. And this program is also in the reference page. You can download test2lower.cpp to run this program. And the next, let's see the implementation of the to-lower function. The input is a character, and the output is also a character. And because and here we use the data type integer because integer can represent a character. And first we need to determine whether the input is a letter in lowercase. First we need to determine whether the input is in uppercase. If the input is not in uppercase, then we don't need to do anything. If the input is not in uppercase, then we simply return the input as the output of this function. So if the input is not in uppercase, then we go to the else part and return the input as the output of this function. However, if the input is in uppercase, then we need to do something. We need to change from uppercase to lowercase. So first we check whether the input is in uppercase. And we have done this before. We have done this in the explorer function. So first we determine whether ch is in uppercase, and we can directly compare ch with character A and compare ch with character Z. And if this is true, if ch is in uppercase, then we need to do something. We need to convert ch from uppercase to lowercase. Then how to do this? This is very simple. To convert from lowercase to uppercase, we subtract letter A in uppercase. First, we perform this subtraction. For example, if your input is letter A in uppercase, then this subtraction yields 0. This because character A minus character A, the result is 0. Then we need to output characters in lowercase. So next we perform addition. We perform addition. We plus character A in lowercase. And for example, if ch is letter A in uppercase, then after the subtraction, the result is 0. And we perform 0 plus lower character A, 0 plus letter A in lowercase. The result is is the same. The result is letter A in lowercase. So this will return letter A in lowercase. And similarly, if ch is letter B in uppercase, then letter B minus letter A, the result is 1. You can check the ASCII table. Letter B is 66. Letter A is 65. So letter B minus letter A is 1. And 1 plus character A in lowercase. Let's see, letter A is 97. And if we perform plus 1, we obtain 98, and which corresponds to character B in lowercase. So if ch is letter B in uppercase, then this expression will return the lower case of ch. And again, we don't need to look up the table. We don't need to look up this table to know the integer value of characters. So we don't need to look up the table to know the integer value of A or Z. We can simply use the character to represent integers. So the first if is better than the second if. The two if are equivalent, but the first one is more readable, and therefore the first if is better. And the next, we will go to the second part. We have finished the introduction of C string, and next we will go to the C++ data type string. And it is recommended that you use C++ string rather than C string, because C++ string is more intuitive to use, and it is more convenient. For example, if we want to declare a C++ string, and we can use the syntax like in this line. And this line declares a variable myString, and the data type is string. And we can use assignment to assign a C string to a C++ string. And we can also use the plus equal operator to perform string concatenation. Here I declare a C++ string, and I assign a C string hello to this C+ string. And you see that this assignment is legal. We can directly use the assignment operator. We can directly use the assignment operator to assign a C string to a C++ string. And remember that, recall that for C strings, we cannot use equality, we cannot use assignment operator to assign a C string to another C string. But for this example, we can use the assignment operator to assign a C string to a C++ string. And if we want to perform string concatenation, we can use the plus equal operator. And after this string concatenation, the result is hello world. And it is very convenient. You don't need to call the function stringcate. So to concatenate two strings, we can use the plus equal operator. And this is very convenient if you compare to the string concatenation in in the C programming language. If in C programming language, to concatenate two strings, we need to call the stringcate function, and we also need to make sure that the capacity of the first input is large enough to contain the two strings. And to access the elements of C++ string, we can use bracket or the at function. For example, to access the element of CPP string, and here I want to print the first character. So we can use bracket to we can use the bracket this syntax to access the element of string of this C++ string. And you can also use the at function to access the element of the C++ string. But if your index is beyond the legal range, if your index is beyond the legal range, for example, if the index is 20, then the at function will throw an exception of out of range. But if you use the bracket, use the bracket syntax, the usage of the bracket will not throw an exception. So if you want to use the bracket syntax, you need to ensure that the index is inside the legal range. Let's intro. I will delay the introduction of initialization to the next lecture. So let's end here.